formulas today. We've kind of done all the formulas that we need. We're going to do what are called composite objects. It means you take two shapes and put them together. I made the front of this review. So this is not new. The front of the sheet is review. On the back, we're going to do some composite shapes, okay? So the front of this is simply review. A cereal box is 12 inches tall. Read the rest of it. 1.7 inches wide, 8 inches long. You're going to look on your formula sheet and find something that looks like a cereal box. It's going to be this one. It's called a prism. All right. Look at your volume. It's length times width times height. You're simply going to multiply all of those dimensions together. So it's going to be 12 times 1.75 times 8. It'll stop eventually. What I am going to do, I'm going to do the entire first side of the paper and then go to the calculator and do them all at once so that I don't have to keep going back and forth from the paper to the calculator. All right, but we're going to type it just like it looks. This is a cylinder and it says find volume. So what you're going to do, and I gave you all a formula sheet, follow along with me. You're going to find the cylinder. It's the one that looks like a soup can. And we're going to do volume. It is pi r squared h. Pi r squared h. It's this one right here. I'm going to take this off of the projector, but you have it in front of you, all right? So we want to do pi r squared h. I kind of just set it up blank, and then we're going to go fill it in. What is r? What is the radius of the cylinder? Yep. 7.2 goes right there. And then h is the height. That would be 14. Cool. Again, I'm going to go through and fill everything out, and then I'll go and do the all on the calculator at once so that we're not going back and forth, right? Now this says hemisphere. A sphere is, a globe, it's round, like a soccer ball or like a basketball. A hemisphere is half of a sphere. So hemisphere is half of a sphere. You got a seat right there. I will make the test available as soon as I can, but I'm in the middle of teaching this real quick, okay? All right. Half of a sphere. And it says, what is its radius? So we're going to find our volume for a sphere, and we're going to do half of it, okay? So half of a sphere. So find your sphere. Looks like a basketball. It is 4/3 pi r cubed. I'm pointing to it, but do you see it on your paper? Like when you take your test, you're going to have to find the right formula. And there's a lot of things on here, right? Perfect. Thank you for communicating with me. All right. Yeah. Oh, not for a while. Not until after spring break, I think. I don't remember. But don't we just have next week and then it's spring break? Yeah, there's no way it's going to be before spring break. All right. So 4/3 pi r cubed. So we're going to do half of that. So 4/3 pi r cubed. Again, it's half because it said hemisphere. And it says, what is the radius? I don't know what this is. So what letter am I going to need to put there? Perfect. X. And this equals whatever they said it equaled. So it is 6.174 pi. It just equals whatever it said. Again, I'll type that in the calculator in just a second. Right here, we are comparing two cylindrical candles that cost the same, and we want to see which one has more volume. So we've got a vanilla candle and we've got a cinnamon candle. So we're going to do vanilla. We're going to do cinnamon. And we're going to compare them. So we got to find cylinder on our formula sheet. It's the one that looks like a soup can or like a candle, right? So find your cylinder on your formula sheet. It is right here. And your volume is pi r squared h, right there. Pi r squared h. So I'm going to do that for both of these. Pi r squared h. I'm just going to set it up blank. And then we're going to have to read and find what numbers we're plugging in there. And then again, I'll put it in the calculator. So while I'm making this test available here just right quick, can anyone find any information about the vanilla candle while I'm logging in here? Can you read and just find something about the vanilla candle? Like, is there some dimension they gave us? Like a number. We need some math, All right, 4.25 is the what for the vanilla candle? That's height. All right, 4.25 goes here. Perfect. Now I need the radius for the vanilla candle. It doesn't give us the radius. It gives us diameter. How do you get from the diameter to the radius? Like the diameter is the whole way across, so the radius is half of that. So it would be 3.5 divided in half. We're just going to divide it by 2. All right, can you read through and find, we want the same information for the cinnamon candle. So can you find like the height of the cinnamon candle? 4.5 goes right here. And I think they did the same thing. I think they gave the diameter for that. Can you find the diameter of the cinnamon candle? Okay, so if it's 3.25, again, I'm going to have to take 3.25 and divide it in half. The radius is half of the diameter. And so again, I'll put that in the calculator and we'll see which one is larger. All right, you are on Performance Matters. Let me know if you have a question. All right, and then last one on the front, and then I'll go put them all in the calculator. And I want you to watch while I'm typing them in the calculator, because if you can't type them in, you're not going to be able to get through this. Right? This says volume, and it says sphere. So on your formula sheet, go and find the sphere. It looks like a basketball. And we want volume. So right here, 4/3 pi r to the third. 4/3 pi r cubed. So I'm going to set that up. 4/3 pi r cubed. And I think they did the same thing here. Yeah, they don't give us the radius. They give us the diameter. So if our diameter is 10, how would I get the radius? Yeah, divide it by 2. Could we do 10 divided by 2 without me needing to write divided by 2? Like, what is half of 10? 5. So let's just go ahead and put 5 there. All right, I'm going to go to the calculator, and we're going to type all these in. Please don't zone out during this part. Okay, look. When you're taking a test, you're going to have to type in your calculator. So make sure that you watch and you're good with the parentheses. It'll only take but a minute. Also, if I mess up, you guys get to be like, hey, Ms. Cole, you messed up. So watch what I type. And if I mistype something, you can yell at me. All right. So what's the first one? 12 times 1.75 times 8. All right. Answer for the first one is 168. All right, that next one is, how do we get pi on here? Pi. All right, pi, and then it was 7.2 squared times 14. So the next one is 2280. 2,280. All right, the next one was a hemisphere, so we want half of the sphere formula. So 4/3 pi. Oh, this was x to the third. All right, so I typed it that way. And then I'm going to come down to the next box and put y equals whatever it was. So what did it equal? It was 174 pi. I need to find the intersection, so I'm going to zoom out a little bit. Click right here, and our radius is 2.1, right there. So 2.1 is the answer for number 3. All right, this is the vanilla candle and the cinnamon candle. We're going to do both and then see which one's larger. The larger one is the one we would want to buy. I don't know who would compare their candles like this. I would go based on what the scent is, but. All right, 3.5 divided by 2. Again, why did we divide by 2? Like, how come we did that? Gave the diameter, and we want... It's good vocabulary. Perfect. Nice. Nailing this. Nice. All right, so that's the vanilla one, 40.9. So vanilla is 40.9. And I'm going to do the exact same thing. I'm going to just alter this a little bit. What was it? 3.25 and then 4.5. So cinnamon is 37.3. So which one would you want to buy? Vanilla. It's larger. You get more candle. All right, and then the last one was that sphere. So 4/3 pi 5 to the third, 523.6. Are you all seeing where I'm putting parentheses and how you get pi on the calculator, et cetera, et cetera? When you're taking the test, you can't go, hey, how do I type this? Like, you're going to have to know how to type. All right, go ahead, flip over. We'll do the ones on the back. I don't feel like we need a brain break. You guys are with me? I think we're doing okay. We're just going to finish it up. This picture didn't fully print, which is really annoying. All right, so we're going to have to sort of draw the rest of the house. If you don't mind, like, extending this down. I'm not here to grade your art skills, but we need to finish the rest of the house, and I'll tell you what the other dimensions were. This was 12. across the bottom was, let me see, I have it written down here, 42. So this is 42 across here. And then front to back is 30. I apologize. I didn't realize that it didn't print all the way. Sorry. So this is what's called a composite object. We're taking two objects and mushing them together. So we're going to do the volume of this bottom part of the house, and then we're going to do the volume of the triangular part and just add them together. Does that make sense? Add it together to get the whole volume. So for the rectangular prism on the bottom, that's the one that looks like this, looks like a Christmas present. All you do is multiply the three numbers together. It's length times width times height. So it's going to be 30 times 42 times 12. That's for the bottom part of the house. Plus, and now we're going to add the top part, the triangular part, like the roof. So if you look at your formula sheet, that's this one. It looks kind of like a wedge of cheese, all right? The triangular prism. So look at your volume. It's capital B times the height. Capital B is the area of that shape, which is a triangle. Following me here? So now you're going to need to find your triangle on your formula sheet, which is right here. Do you see where I'm pointing? Triangle. All right. Area is 1/2 base times height. So we are going to have to do 1/2 base times height. That's for our triangle. And we're going to multiply that by this dimension of the house. We're going to do this triangle and then times 30, how far back it goes. So let's do the base times height for our triangle. I'm going to try and highlight this so you can sort here. I'll make it red. This would be the base, and then this would be the height. One of those we're going to have to do a little side problem to find. What would this dimension be, though? What is the base? That's the same as this, so it's how much? Yeah, 42 is the base of that. Now, to get the height, we're going to need to look at this triangle right here. This triangle right here. Is that highlighter showing up on there? Okay. All right. It's going to be your Pythagorean theorem. We're going to do x squared plus, and then I need this amount. If the whole thing is 42, how much is just this piece of it? We would do 42 and then what to get just this part? It is 21. How'd you get 21? Nice job. Whoever said that back there. Divide it by 2. All right. So x squared plus 21 squared, it's half of 42, equals what squared? We did x squared, 21 squared, and then it's going to equal 29 squared. Okay, so I'm going to go put that in the calculator, and we're going to see what the dimension of our house is here. That one was hard. It was not easy. We had to look at a lot of different dimensions, and we're going to have to do Pythagorean theorem. All right, so x squared plus, the only thing, I think this does come out to a whole number, which is nice. So let me move this. We're going to click right here, and it is, I think it's just 20, right? 20. Cool. So 20 goes right here, and then you would type this entire thing in with all the parentheses and everything. I think you should be good with that. I'm not going to make you watch me type that. I did all the ones on the front, so I think we're okay. All right. But sometimes you will need to do your Pythagorean theorem to get a piece of it that you're missing. All right, number 7. We have a sphere. We have the top and bottom of a sphere, and then what shape is this one in the middle? You have the sphere that's on either side, and then what's the one in the middle? Begins with a C. Can anyone find it? Looks like a soup can. Cylinder. Good. All right. We're going to find volume and surface area. All right. So let's do volume first. Can you find on your formula sheet volume of a sphere? Yes. Okay. How does it start? I don't want to keep pointing to it because you guys have to be able to find it. Volume for a sphere. 4/3. Good. Pi r cubed. All right. Does it say what r is? I don't see it in the picture. We got to read and find it. Oh, it says the diameter is 16. So what does that mean r is? If the whole way across is 16, then the radius is 8. It's half of that. Good job. All right. So that's the sphere. And then we're going to add on the cylinder. So on your formula sheet, again, I don't want to keep pointing to it because you have to be able to find it. Find the cylinder, find the volume. Perfect. Pi r squared h. Now we just said r was 8. We just found that. What is h? What's the height of the cylinder? 12. Cool. And then you put that in the calculator. I'm not going to make you watch me type that. I typed all the ones on the front. All right, surface area. We're going to do our surface area for our sphere. So find your sphere. It looks like a soccer ball. And look for surface area. It is 4 pi r squared. And what did we say r was? We just did it 8. Perfect. Plus, now this is tricky. For the cylinder, you only want this part around the outside. You don't want the top and the bottom because that's where they're connected. So when you find your cylinder, do you see where it says LA? That is lateral area. That's just the amount around the outside. So that's the one we want, lateral area, just around the outside. So it is 2 pi RH. This is the one we want right there, 2 pi RH. So plus 2 pi, R is 8, and height is 12. Whatever that is in the calculator, that's your answer. Cool. 2 more. Hang in there with me. We're a third of the way through the block because the bell's just rang. All right, find the volume of the object. So we're going to do the entire thing and then subtract out this cylinder that got punched through it. All right. So the whole object is going to be this 8 times 7 times 6. You're just going to multiply all those together. And then you're going to subtract the cylinder. So you want to subtract this cylinder that got punched out of the middle. So you're going to find on your formula sheet, cylinder volume. So cylinder volume. Find the one that looks like a soup can. Pi r squared h. So pi r squared h. Now the radius isn't written in the picture, so that means it's got to be somewhere in the problem. It says diameter is 4. So perfect. Radius would be 2. And then the height of the cylinder is this dimension. Your height of your cylinder goes from front to back. So the height would be 6. Good. Whatever that is in the calculator. So you do the whole thing minus the cylinder. And then last one. This is tennis balls in a container. First of all, it says the whole height is 30 centimeters. What does that mean each one of these is then? If the whole thing's 30, each one, good, is 10. And if the diameter is 10, that means the radius is 5. So the radius of this is 5. So what is the question asking? We want volume of the space not occupied by the tennis balls. So we're going to do the whole thing minus the tennis balls. So the whole thing is a cylinder. You're going to find cylinder on here. You're going to find volume. It is pi r squared h. You can do it. All right, we just said R is 5, and the height of the whole thing is 30. Minus, and then we're going to subtract the tennis balls. So how many tennis balls are there? 3. And they are spheres. So we're going to multiply this by our sphere volume. So there's 3 of them, and we want spheres. So it is 4/3 pi r cubed. And we said our radius is 5. So you want the whole cylinder, and you're subtracting 3 of the tennis balls. And again, I made you watch me type all the ones on the front page. I think you're okay with the calculator, so I'm not going to make you watch me type them in the calculator.